All right, I can go ahead and introduce us. So I guess we'll get started. Try to wrap this up in a reasonable amount of time. I'm Jamey Sharp. My current employer is Galois, and here's my friend and colleague and fellow rocket scientist Theo, speaking for the Tova company. So if you want to get us started.
Yeah. So today we want to kind of talk about the GL extension OML Sync Control. Just kind of get an overview, and then eventually have kind of a discussion about the state of it, where it's going, what kind of we can hopefully expect from the future, and we kind of want to hear from everyone here about what's going on with it. So what is it? The first thing everybody always asks is, what does OML stand for? And helpfully, OML stands for OpenML. The ML, I believe, here stands for Media Library. It is a Kronos spec. It doesn't really seem to have any use outside of GLX OML Sync Control that I can tell. I think there is possibly a hold it closer, thanks. I believe there is a WGL spec defined, but no implementation, none that I found. So it is used for syncing buffer swaps to vertical retrace. EXT swap control does it, but as far as I'm aware, EXT swap control only allows you to coordinate swap buffers on vsync. OML Sync Control, on the other hand, it provides a lot more capabilities. It allows you to explicitly schedule a buffer swap to occur on a certain vsync, and after that, it will report back to you whether or not it was able to make that deadline and at what time that buffer swap actually occurred. So for a lot of people, this doesn't seem to be terribly useful, is the impression that I've gotten talking to people. But it is very useful for neuroscience. I work at the Tova company. We produce a test that it tests for attention problems in people. So we look for things like traumatic brain injury or attention deficit disorder. What we do is we flash an image on the screen and measure the time it takes for a user to press a button in response to that image. So what we need is a way to say exactly when that image got to the screen, and we need to then know exactly when it was on the screen, if the hardware was able to satisfy a request.
There are many more issues beyond this one,
yes.
But this is among the issues that have to be dealt with here.
I know a lot of you have talked to Mario as well. He does a lot more complex things than we do. He has a full neuropsych toolbox for doing a whole battery of tests and things like that. So the major components of OML Sync Control, it operates on these three counters. UST, which is unmodified system time, which is a sort of a common time base for what was originally intended to be able to sync multimedia across audio and visual and possibly different devices. The media sync counter, MSC here, is the number of vsyncs that have occurred since some arbitrary start time. And that's specific to the graphics device. SBC here is the number of buffer swaps that your particular drawable has had occur. So these are the, I guess, the functions. These are the functions defined by the spec. Get sync values will return the current values of those three previous counters. It's nice. It usually works. Get MSC rate returns the frequency at which MSC will be incremented. GLX SwapBuffers MSC OML is, I guess, the real workhorse function in the spec. It allows you to specify a target MSC that you want your buffer to be swapped at, and then it will go ahead and schedule that. You can optionally provide a divisor and remainder of how you want
to deal with missed target MSCs.
Yes.
So if it couldn't satisfy the target MSC request you asked for, then it will wait till the next time that the MSC mod the divisor equals the remainder.
Yes. And then we have these two wait functions that will allow you to alternatively wait for target MSC or target SBC. So that you can possibly wait until your frame has actually showed up on the screen and then go ahead and check afterwards.
So some things that may be surprising if you go and try and actually read the OML Sync Control spec. One thing is that, so there's this notion of divisor and remainder. If you set the divisor to 0, what Mario and what we sort of expected from reading the spec is that what that meant is that the divisor and remainder just don't matter. You'll always still get synchronized to vertical retrace. Chris Wilson argues, and after really, really carefully reading the one relevant sentence in the spec, I think I agree, that divisor equals 0 actually means that if it's missed your target MSC, then it's allowed to swap at any time, including not synced to vertical retrace, which is bizarre, but that seems to be allowed.
And more importantly, that's how it's implemented.
The sentence is absolutely very unclear, as Mario says.
I will never do that.
Your driver does do that.
Not the UXA driver does not.
Yes, it does.
Yes, it does.
Only if you ask for async.
The UXA driver, absolutely, if divisor equals 0 and it missed the target MSC, it will swap whenever it feels like it.
But at V-blank time.
No, it won't wait for VBlank. If it missed the target MSC and divisor is 0, the UXA driver will swap at any time.
That's wrong.
So we agreed this is strange. It's easy enough to work around. If you set divisor to 1, then it's very clear what should happen, and I think everything gets it right. So I'm not particularly worried about this. Other interesting things, I noticed in reading the existing Piglit tests for this spec that that they attempt to deal with things like what happens if these various int64 counters wrap.
It's not entirely clear what negative values for UST, MSC, and SBC mean.
Particularly because -1 is used as an error value in a number of places for these things. So we wound up concluding that for our purposes, we just, these will never wrap, so we won't care.
Actually, they do. The SBC wraps, but only in server version 115 or
Sorry,
something.
how can SBC wrap in a 64-bit value when it's
I don't
required?
sometimes
It's required to start at 0 for the window. Like, how can you ever have a machine?
Oh, it
run
was the
for-
MSC. I'm not sure. Was it? I think it was the MSC.
At
So
60 hertz, MSC should take something like 2 or 4 billion years to wrap.
yeah, I think it might be a server bug, a relatively new one. But
Those are bugs.
sometimes it starts by minus 14,000 and then it counts backwards, minus 30,999, 998.
That sounds like maybe there was a bug where it was being computed in a 32-bit.
Yeah, it could be something like an
and then-
uninitialized value somewhere.
Oh, there's that
But,
too. Yeah, uninitialized.
it
value.
wasn't there in the past. It's something relatively new.
You think the spec's clear about divisor equals 0?
The literal text is, if divisor equals 0, swap or when the MSC becomes greater than or equal to the target. That literally means any time at once. Like I can't think of any other way to interpret that.
I mean,
I don't actually want to have this discussion because I don't care about the answer. Moving on. So one thing in the at least open source implementation is that it's fairly common for things to return for the drivers to return values of 0 for UST or MSC if they don't actually know what the right answer is. And so this, if this ever happens, it always violates the spec, which says that these values need to be monotonic. And so you're observing non-monotonic values. This is clearly a spec violation. It's kind of non-trivial to fix in many cases, but we'll come back to that. What did we mean by get sync value scheduling? That was. Oh yes, if you one of the things that we did in one of our incarnations of our Piglit tests was in order to deal with the previous issue of the drivers may return zeros in places they're not supposed to, was immediately after waiting for SBC, we'd go call get sync values and see what value we got back. And Chris Wilson rightly pointed out that scheduling delays might mean that you get different answers if you got scheduled 16 milliseconds later, which seems unlikely, but could happen. There's also the point that this spec deliberately does not specify what UST means beyond that it's monotonic. So these values are meaningless outside of the spec itself, which makes it particularly interesting that earlier this year, to help with porting Chromium to EGL, some folks that I know well were working on a partial EGL extension that does only the get sync values part of OML Sync Control, which it's not at all clear to me why anyone would ever want this. And I tried to get them to find out why Google wants this, and they're like, no, this is what we're doing. We're just going to do it. The last thing, this one's kind of fun. If you've gone through the implementation of the open source drivers and discovered that how UST is actually implemented on Linux, at least, is as the clock monotonic POSIX clock expressed in microseconds, then that gives you the opportunity to, from user space, go compare what the timestamp was that the server told you the swap happened at with what time it is when the server told you this. And if you do that, what you will find out is that you're getting timestamps from the future, which is very exciting. It's correct, yes. As Keith says, it's absolutely correct. It just was very confusing for a little while. The drivers are going to a great deal of trouble to work out, okay, we've gotten into the vertical blanking interval, we've done the swap, and at some point in the future, the vertical blanking interval will end, and that's the time that we're going to report.
You're supposed to report the time the very first pixel gets illuminated on the screen for the new frame.
I'll just repeat what Keith said. We're supposed to report the very first time, the time that the very first pixel is illuminated in the new frame. I don't recall actually reading that in the text of the spec, but it's absolutely the useful thing to do at any rate. Okay. All right. So that was just a little bit surprising. Very handy, but kind of surprising. So there's a bunch of assertions in the spec. We wanted to, in order to make sure that this extension was actually usable for the stuff the Tova company needs, we wanted to go and actually write Piglit tests. And so here are some of the assertions that we wanted to check. It says that the swap buffer count for a new window starts at 0. Counters don't ever go backwards, so they're always monotonic. When you use the SwapBuffers request, it should be scheduling SBC 1 greater than the last swap buffer count you had, which is a quite natural thing. It shouldn't ever execute the swap before the target MSC you asked for. It might execute it later. That's permitted. So if it executes it before, we report that as a fail. If it executes it after, we report it as a warn. Just something you might want to know about. If it did miss, then it had better respect whatever divisor and remainder you set. And related to the earlier thing, if SBC changed without you having asked for a swap, then that's clearly a bug. So assortment of obvious things to look for. Slightly less obvious, we do some statistics. I mean, what we really want to know is the driver actually swapping during the vertical blanking interval, or is it just doing it whenever it pleases? We check two different things. One is UST advancing at a consistent rate with respect to the rate that MSC is advancing? So we compute the standard deviation of those ratios. And if it's too wildly inconsistent, we warn about that and consider it suspicious. But since there is no spec for what UST actually means beyond that it's monotonic, that can't actually be a fail. But we also compare wall clock time as observed in the client. And so if the time elapsed between wait for SBC calls completing over the number of MSCs that were supposed to have elapsed in that same period, if the standard deviation of that is greater than a millisecond, that's fairly strong evidence that it's not actually syncing to vertical retrace. We could probably even say if it was, you could probably set the threshold lower than that, but also if the average time between MSCs is dramatically different than the amount of time you'd expect given what the refresh rate is supposed to be, then that's also a pretty strong hint that something's gone wrong. Now another piece that we did, in addition to putting together Piglit tests, is if there's ever a point in a driver where it passes a constant value for UST or MSC, this must necessarily be a bug. Now, you may be able to fix it by going and picking values, returning the result of calling random or something. But this is at least a hint. If there are constants in there, typically zeros, that's a code path that should be checked to figure out what should the result have been. So I put together a patch for the X server, which I've gotten absolutely zero review comments on. I think it got entirely ignored. That if you're compiling the driver with GCC, it will go use built-in constant p to check whether these values that are being passed to these functions are constant. And it will both give a compile time warning, and if that code path is actually hit, it will, the first time it's hit, log that in the X.Org log that you hit it and give you some details about what happened. So I thought that seemed kind of useful. It'd be nice to be able to give the driver developers this kind of feedback. So if that could get merged, I'd kind of like that. So some interesting results from actually using that patch. This is the resulting output from UXA, for instance. And I'm going to pick on Intel only because I have Intel hardware. So that was the most convenient thing for me to test with. So there are 3 warnings out of this. Our Piglit tests only actually trigger one of these code paths. I'm not really sure what the other 2 are. So for the one that we actually hit in testing, I proposed a patch for fixing it, which Chris Wilson-Nacht, which I'm a little miffed about. Until late May, if you used the same X server patch and built SNA, you got a lot more noise. What Chris did in May was changed all of these to report something. I'm not entirely convinced that what he changed it to report is the right thing, but it does report non-constant values now, so that's something. So let's actually have a look at the results from our Piglit tests. At least in the versions we tested, and if you want to know details, you can ask us later. Nouveau actually passed all our tests, so nice work, folks. Radeon passed but warned in a couple of cases.
It missed MSC's target by 1 usually.
Ah, okay. So maybe a little bit of a scheduling issue of some sort, scheduling page flips or something. SNA had a bunch of issues, and UXA has one issue that that my patch fixes reliably, but I haven't been able to get the Intel driver folks to merge. So now one of the speaking of not being able to get people to merge things, we wrote these Piglit patches in April. We had a detailed exchange. Well, Eric reviewed them and gave us some good review feedback, and Chris Wilson gave us a detailed critique on our interpretation of OML Sync Control. And then after we'd addressed all of Chris's concerns, he went away without acknowledging us further, and we've had no luck at actually getting these patches merged.
Keep it down for merge because I'm tired of waiting for Chris to be happy.
Thank you, Eric. I appreciate it. I do want to complain just a little bit more, though, just in the sense that people complain about getting stuff merged into the X server. I know how to get stuff merged into the X server. There was an X server release where I had more patches than anyone else in that release. Being unable to get stuff merged to Piglit for months is really frustrating. No one can get stuff merged in Piglit? I was sort of wondering, like, if I can't, how can anyone? Adam has an opinion.
Do we think that that's because someone owns Piglit and we're like waiting for their blessing, or is that because we're too chicken to push patches? Because like when I push things to Piglit, I pretty much just do it and don't ask for permission, and I have rarely been expected to beg for forgiveness. Maybe I'm just like good at it, but I'm kind of wondering, is this a social problem of being too polite and expecting somebody to like beg for blessing, or because seriously, I would it's a test suite with no release manager and no release and no even dream of a release schedule. Do it. And if somebody really thinks you're wrong enough, they'll revert it.
Right. We had this conversation. You and I had this conversation on IRC at the time we were doing this, and someone immediately came back with, "No, this should get reviewed." So I'm like, "Okay, I'll wait for it to get merged."
I think what most people do is
I think what most people do and what's kind of generally acceptable is send things out for review, and if all you get is crickets, then go for the beg for forgiveness route. I think part of the reason why nobody gets anything landed in Piglit is you send something out for review, you wait a couple of weeks, and then you forget that you sent it out for review. And then 6 months later, you're like, oh my God, I have 80 patches sitting in my Piglit tree that I haven't pushed. Okay.
I forget if I have commit access to anything in X.Org, can I commit to everything? Not to Piglit. So yes, I do not actually have the commit bit for Piglit. So that's the other problem. Right. Yeah. So we want to conclude here with some time for discussion and time for Eric to have a seizure from. It is important to test full screen on this because otherwise there's some very important page flipping paths you're not actually testing, and we use bright green because.
That's a nice color.
Yes.
I think it was the color that other tests seem to use. So
Yes.
Color of success.
Yes. So yes, seizure-inducing tests aside, So, strong work to Nouveau for not apparently needing any patches. It would be great if, as these get merged, if we could get the driver developers to. What is that glare for?
I think it's the full screen.
Oh, we should note, when we run these tests, we're running them in not under a compositor.
Yes.
Yeah, just so that's clear. If you try this under a compositor, you probably get much worse results.
The only way you can actually trust the values is if you have KMS page flipping. So it must be unredirected and it must work with KMS page flipping. Everything you get with the old path with copy swaps or going through compositor is basically more or less fantasy. It's an optimistic view of the system, what might be roughly the time where it really shows up.
DRI1 had page flipping. DRI2, I'm pretty sure had page flipping. Are you just comparing them because you like to?
No, that's not what that's not what Mario is saying. What he's saying is that if you are if your implementation is not using page flipping, then this is all bogus. You disagree with that?
If you can trust it to the extent that if you're not redirected, your bits got on screen way faster. If you can't do that with a flick, your driver is broken. Period.
I agree that that should be true. Just for the recording, Ajax's claim is that if you can't get things onto the actual scan-out buffer using a blit within the time of the vertical blanking interval, then your driver is busted.
Pick me.
Yeah, so Mesa is not actually fast enough to do that.
Mesa's not involved.
If you're using Glamor, it is.
Okay.
Mesa takes a long time to get stuff on the screen.
Really?
The vertical blanking interval is very short these days. Or shorter. And Mesa cannot actually do a blit in that amount of time. It's painful.
And depending on what else your GPU is doing at the same time.
Oh no, if the GPU is idle, Mesa still will reliably fail.
Maybe that, but certainly if your GPU is busy doing other stuff.
Yeah. Yep.
And is that because it's doing the blur using two triangles?
No, I do the blit with a single triangle. That's
what?
kind of bigger than you think it should be, yeah. No, it literally just takes too long for Mesa to get around to getting the commands out to the GPU. I'm usually down about scan line 30 by the time Mesa pushes stuff out. Yeah. If you could make Mesa faster, that would be awesome.
That sounds like a nice thing.
That's one problem because the timestamping at the moment, it just assumes, basically if you do a copy swap, then the timestamp you get is the timestamp when the copy area request was submitted. DRI2 copy area, basically. We take the vblank time.
Glamor, you can find out when the copy was done. Right?
That is a thing we could do.
Yes, we could do that.
That sounds nice. I like that plan.
Yeah, so that's.
Oh, but you have to either block or pull for that, though. You don't have an FD to wait on.
Well, and the copy is going to be done long after the first pixel of the copy was done.
Can you use like timer query or something like that? Well, yeah, that's what I was thinking, is using the timer query to find out when it actually got done.
But you don't
You
care
can-
when it got done. You care
You can
when.
at least drop the timer query when you start.
Right.
Yeah, but what you actually
Just
want to
better.
know is when you start a blit, where is the scan out relative to the blit? So what you've blitted, will it show up in the next retrace
Oh,
cycle because
also-
the scan out has already passed?
Timer
Or
queries aren't on the same time base.
Timer queries aren't on the same pi base. Awesome.
What? They're on the GPU's timestamp. Not clock monotonic.
yeah, you basically
I have a
you
clock
would
monotonic over there. Well, I have a monotonic clock.
you would need to remap.
So then maybe, I mean,
It's a
Because
different
the spec
crystal.
doesn't say what, and this issue right here is part of the reason why the spec doesn't say what the time is relative to. You can make it so that on drivers using Glamor or other drivers, they return whatever that magic QB clock is.
Well, they don't even tell you what the units are.
Yeah.
And this is
Yeah.
why.
OML,
Because
yeah.
people had different, I mean, at the time when this spec was first shipped, what a lot of people were doing was they were using RDTSC or moral equivalent of it on their platform, right? And other people actually had a magic clock counter that was in their GPU that they would read. So it's some number that increments.
Yeah.
So I guess a question I have for those of you working on Glamor is how much of this stuff is currently implemented in Glamor?
I'm
All right, take the microphone.
Glamor isn't.
Yeah, I'm not sure that Glamor is really the right thing to be asking this about
I didn't
because
actually
it doesn't
think
really
it was,
it
but-
doesn't implement the page flipping or any of that itself. So I have patches out on the list for DRI2 for mode setting.
Okay.
Hopefully, present will be to follow shortly once I fix the bugs in the DRI2 bits. Sorry about that. So yeah, I actually was just running your tests on the mode setting driver, which was what was all the seizures were about. Yeah, I think we should be able to get video mode setting to be the same level of conformance as certainly the EXA driver. Hopefully, we can come up with something to fix the triple buffering problem.
Right.
That probably just requires a little more thought, which I haven't applied yet because so far I've just been cargo culting all of that code over.
It's not triple buffering. It's quad buffering.
So I'm not quad buffering in x86 video or mode settings. So no, I'm not. I deleted that code. I didn't port it over.
Mesa quad buffers on DRI3.
Oh, you're talking about DRI3. I'm talking only about DRI2 right now. Yeah, so then hopefully doing present sometime soon. Hopefully before the merge closes.
For a piece of context here, the triple buffering question is the issue we encountered with the EXA driver is that the path that attempts to enable triple buffering for performance reasons, I guess, does it by lying about SwapBuffers completing. And so my patch that makes OML Sync Control spec compliant in UXA makes it not lie anymore, and I'm told breaks triple buffering. So yay. We can't have nice things.
Yeah, that's the way I do it on Intel, basically. I do X.Org to disable triple buffering. And we had some kind of pseudo triple buffering in Nouveau, which we now removed because it caused more problems than.
Well, if
than
you use
good.
DRI3, then Mesa's responsible for the buffering, and Mesa will use double, triple, or quad, single, double, triple, or quad buffering, depending upon what you've set your vertical blank options to.
This is the vblank mode equals 0 through 3 thing?
Right. No. If you have your vblank mode,
We're going to have to stop and go to the next talk. Sorry.
that's okay.
We can discuss later. Thank you. So next speaker, please.